if you hadn't said that, I mean, I couldn't have started my presentation, so I really appreciate it. I really think that, star schema and analytics has been almost around forever, right? And in fact, I would basically go as far to say BI and reporting. Somebody was talking about visualization, and there are aspects of visualization which are not well understood. But in general, BI and reporting, to report some KPIs on businesses, are well understood, at least from an infrastructure point of view. Okay, and my journey has been along these analytic chain. Also, so I was in Sybase, and we were processing data, and data management was an important aspect of it. I was there around 2000, early 2000 to about 2005. I was a cluster manager, architect, and then I was at Cognos for about 2 years, where we provided reporting applications. And both at Cognos and Sybase, one thing which we constantly found was the fact that even though we were providing a lot of reports, we were actually going and telling people, okay, this is what happened before. It really did not, we were not able to drive decisions, right? We were not able to actually go and get actionability out of it, and that was one of the biggest failures that I had. I founded a company called Jovian Data. Jovian Data's tagline was pivot table on terabytes of data, and it came from the fact that volumes of data were increasing around 2008. Cloud computing was just coming along, and you could just spin up. I still remember the moment in October 2008 when I logged into my AWS account, and I just had like a credit card. I swiped it, I brought up 100 machines, and then I used it for an hour, and I brought it down, and it cost me $10, right? Something which was not available before that. And so we saw the emergence of cloud computing, and then we also saw that huge volumes of data were getting generated, so we formed a company called Jovian Data. And the idea was to basically be able to answer any query on the data in reasonable time. And then at the end of the day, after about a couple of years of work, we were able to answer queries on about a terabyte and a half in less than like 20 seconds, 15 to 20 seconds, which is great. And then we provided all kinds of segmentation, clustering, and market basket analysis, and so on and so forth. So we were able to describe what was happening within the data, and we were getting better at it, right? And why certain things were happening, right? That is useful. But we still were not able to go and tell Chrysler, which was one of the companies that we were working with, where we were trying to analyze their advertising campaigns, that this is what happened, this is what you're supposed to do the next quarter or next month or the next campaign, right? So then we got acquired by MarketShare, and the head of engineering of MarketShare had been working on this problem for about 4 years. And what MarketShare does is something different. Looks at the data. We still basically get the data in. We do create KPIs on top of the data so that we understand the business, right? We understand what's happening within the data, and then we create models on top of the data, right? We use regression, linear and logistic regression, to basically go and create models. And using these models, we forecast what is going to happen tomorrow, right? And then, using these same models, then we build optimization algorithms on top of it to say what is the best that you could do going forward in the future, right? And I believe that this whole hoopla about data science is this. I heard that somewhere I read in LinkedIn yesterday, Workday acquired a company which actually can predict when an employee can quit. All of us who've been managers, that's awesome, right? That's our biggest challenge today in terms of attrition and so on and so forth. There's a whole hoopla about, can I basically, with all this data present, can I forecast? And more importantly, can you tell me what I need to do, right? And I really think that only when you reach this stage can you actually go and provide value. And what I'm going to be talking about is how did we get there? What was our journey from in journey data when we were a descriptive analytics company where we were looking at star schema and we were providing reports, complex reports, for some large volumes of data. How did we actually go, and what does it take to basically go and build forecasts and optimization? A little bit of history about the company. We were a consulting company. We were founded in around 2005. We were a consultancy company for a long period of time, and we were working with top brands. Our founders have background in advertising, as well as one of our founders is a professor of marketing at UCLA. So they have background in the analytics area. Also, we did that about for 4 years. Then we built a product, and for the past 4 years, we've been providing a product as a service, a software as a service product, targeted towards marketing. And we help the marketeers optimize their marketing and then maximize their revenue. And we've done reasonably well. Like our revenue has grown 10x, 50% year on year last year, and we are poised for growth next year also, right? So fundamentally, this is the workflow. And typically, in a reporting workflow, you get data and you do some ETL on top of it, and then you provide reports. In modeling, what you do is you actually, after you do ETL, you build models. And again, for optimization, you need to build something on top of the models to create some optimization algorithms, and then you deploy it to the tool. Right? Let me pause right there. How much of this makes sense to folks till now?
It's hard to read from back here.
Okay. Let's try if I'm able to. If I zoom it.
Maybe if you move the table, move the table back.
Yeah, I can try that. The challenge is the cable. I can try it. Is that good?
It's a little bit.
Just refocus.
All right. Thank you. Glad I got asked the question. What else? So make sense so far? So let's go back to that the star schema. I am going to talk from a BI world, right? And by the way, I had the same presentation about a month back, and it was filled with data scientists, and we had a lively conversation on how it is, because I come from the whole BI analytics, and the data science people probably view this slightly differently. So you start with the same star schema, right? You have product, and then in this case, you have number of impressions and spend for the BI folks. These are the two metrics that we are monitoring. You have product, time, and geo. And for the purposes of the example, I've intentionally kept it very simple, right? One level and very few values, right? The first thing that's done is basically the data is completely flattened out. When you build a model, you flatten out the data so that it's like one uniform view, and that's extremely important. And then the next step that folks do is to do something called a feature selection, right? Feature is nothing but a metric. So in this case, there are two metrics, which is TV impressions, called TV impressions, and this is the TV spend, with a context around it. Okay. The only thing about these features, only rule about these features, is the fact that the context all has to be at the same level, right? It's either weak or for that matter, in this case, it's rolled up to it's all regions and then so on and so forth, right? Each feature can be only under one context. And clearly, you can have for the data, you can have lots of features, right? So what you do is you select a set of features, and then those features are actually assembled into an equation, right? And then, as you can see, this equation has a lot of other KPIs, This is a real example. I've just taken these two to highlight, and there are two quotients associated with it. And then what modeling, or they call it estimation, is nothing but is estimating these quotients, and they tell a story by themselves. For example, in this case, if you look at it, the impressions vary on the product, not on the regions, right? And then the spend varies by both product and regions, right? In sense, you have data which varies by both products and regions. But then after estimation, what you find is the quotients itself, the first quotient, actually does vary by all products, but the second quotient, which is for this, does not vary at all. Value is the same, right? Which means that even though you have data and you've selected it, individual members do not have, they do not impact the outcome as much, right? So that's one. And for the infrastructure folks, this has an impact, because then once you've created this model, the way these models are evaluated, at least logically, and there are people who basically go and build all kinds of infrastructure around it, is they take these variables and then they arrange them as columns. They take the quotients, arrange them as another vector, and then it's just a matrix multiplication of the input of the variables arranged as input along with the quotient, which gives you the outcome. And the number of columns in this matrix is exactly the number of quotients that you had in your previous step, right? In this case, we had 4 different quotients, right? Even though you have, like, so many values, 4 different quotients. Therefore, this matrix would have 4 columns, right? And if you had n coefficients, then it would have n columns. Okay.
What's a coefficient?
So okay. So in this equation, I think if you want to evaluate these equations, so you had these variables before, right? There was a constant value which basically went and said how important is that particular value, right? This constant estimates how important that is, right? And usually it is less than 1, right? It's much.
Can you give us an example of what values you're looking at?
So for example, so these are the values, right? In this case, you have TV impressions, right? And then the quotient value, if you look at it, for impressions for comm was 0.04, right?
So it's just basically a weight on that?
It's just a weight on how important that particular value is, right? And together, the quotient and the variable, the value itself, will tell you how important that particular component of the equation is. And then usually there are many variables and many components, right? So you estimate the quotients, you basically come up with the number of quotients, and then you assemble them in a matrix. You do matrix multiplication, you get the outcome. This is what people call as simulations, right? They call, like, how do you run forecast? I mean, this is a simulation, but basically forecast is if you have future data, and somehow you're able to basically get future input on the data, and then you actually go run the model, then you would have forecast.
So here the coefficient stack, that's the weights?
Those are the weights.
Those are the weights. So basically, in the model input, which is your data points, you can say, you're weighing which data point is more important based on those coefficient stack.
Exactly.
Right? So when you multiply this, that'll, so where is the model? What model? So this is the data that's been prepared. Now it's weighted. It's supposed to train the model, right? Or maybe you're using a different methodology.
No, so these are so if you look at it, like, data is normally like this, right? Normally we are used to data like this, right? We have some kind of a context associated with it, and then we have some values here, right? So this is your data, right? And then this is your input data. in the sense that in this case, these are your spend data, and then the impression is another type of spend. You can have paid search and so on and so forth. These are your input data, right? And in our example, we are basically trying to predict the Google query volume, which could be an outcome that we are trying to basically come up with, right? So when you do that, there are obviously hundreds and thousands of input that you can basically go and get. You first figure out what inputs are important for me. You don't select all possible inputs. You select what inputs are important for me, right? And then those inputs are basically assembled in this equation, right? And this could have a lot, and I'll go further in the presentation. It will probably become very clear. But you'll select a subset of them. You'll assemble it in an equation and say, I'm going to work only with these inputs. Rest of the inputs do not matter. Let me work with these inputs, and then get the weights that each inputs actually go and contribute to the outcome, and then you go and predict the outcome, right? And again, it's kind of like I said, it's a BI person basically going and talking about data science, and if you have a data science guy, they'll have a completely different way of actually going and talking about this also. Right. Anyway, bear with me for a moment, and then so this is one, and then one more thing. Once you have this model, then what you can also do what-if analysis on the model, because let's take this data that was there before, and then you can basically go and say, okay, fine, this is my data. What if I increase my spend by 10%, right? Then you can basically go spread that spend across the entire data. You can recreate the matrix, right? You can basically go and actually go and update the matrix with the new value, multiply with the coefficient, and then you can get new values, right? And this is what is called as what-if analysis, in the sense that you have this base data, which I think you get it from the model, and then you can actually go and modify the data, and then you can use the same model to come up with different outcomes, right? Okay.
Is there a logic behind how we can get to weights?
Yeah. So there are, so for example, so you have linear regression, which basically goes there are ways of regressing the data, where there are different ways of basically going and regressing the data, or like coming up with coefficients. We use linear regression to basically go and estimate our models, and that's because we are predicting sales, which is a continuous value. Then you have then I could go into the details of it. Then there are classification algorithms, which is just like true or false thing, and there are ways of basically going and using some other different kind of methods to basically go and estimate these coefficients.
So I guess my next question would be, for the interactive variables, would you have a logic behind that?
The interaction variables. Yeah, so it's how you assemble so we have in our typical models, we have 20 or 25 such equations, and the interactions is captured between what feeds into one, how one equation feeds into another thing. And yes, there are logic associated with how you basically come up.
You just play around with it and then find out what comes back as highest correlated to the sales.
That's right. So in my mind, I think to a certain extent, yes, you need to be able to build a model, you need to be able to forecast, and then you should provide optimized recommendation. And optimization is nothing but you repeatedly run these simulations with different values, and you say, what is the best possible outcome I can get? What combination of input is, very simplistically, what combination of input provides me the best possible outcome? That's optimization in my mind, right? Once you provide an optimized recommendation, it's extremely important that you also be able to provide what-if analysis. Now, what is the challenge, right? So when we joined, when we were acquired by MarketShare, and this is a personal journey, I'm sure all of you guys had your own personal journey. The number of columns that you saw in the matrix, right, or the number of coefficients that were estimated, were about 1,200, right? Simple problem. People were in an Excel spreadsheet. They can basically go and have 1,200 columns, and they can they can basically go and run these calculations, and it was easy. In fact, when we were acquired, the way we were selling it was an Excel macro. That's how we were actually going to our customers, right? Today, the data itself was like, that's the number of elements, so about 195,000 elements, and total data size was about 2 million elements, which is like less than 60, 70 megabytes of data, so it's not. Then around 2013, and people started really getting interested in this kind of analysis. They wanted to do more and more granular analysis, right? So, and you guys will laugh, like, right now, if you look at the data science world, and people are talking about analyzing every individual to a certain extent, we are not doing that. But this is basically Home Depot, who wants to look at about 50 product categories, right, across 10 regions, right? So which is about 500. And then we have like 50 variables, right? So the number of columns now become around that number. And we've got a few more things that basically come into picture. That's all we wanted to analyze, right? And suddenly the model doesn't fit into a single computer. Okay? T-Mobile, which is very different from Home Depot, has a lot more stores, right? And they're not even looking at stores. Lesser number of products have a lot more stores, right? Again, they are doing analytics on top of it, and it's about, right, 50,000 columns, and the data size is already like, multiple gigabytes, right? Each scenario is already multiple gigabytes. This is offline data, right?
It's like cell phone conversations and stuff, right?
Cell
phone conversations.
Now, let's go to online data, all right? Let's look at the numbers, right? And I showed that last month to folks, and then they were like, what the heck, these numbers do not make sense, because they're modelers and they've been doing it for a long period of time. I don't have internet connection here, otherwise I would have showed the scenario analysis. But we have that, the scenario template, and we can walk you through it. There are 547, this is actually Hilton. There are 547 campaigns, 4,650 creators, I'm not even multiplying all of them, right? If I multiply all of them, it's about 2.6 trillion possibilities that you can actually go and have, right? We don't use any of them. If I wanted to build a model, it'll be about 600 million, right? And we are doing that. And then we're working with Universal Studios, where this could easily touch about 700 million columns, right? That's just one simulation. I wanted to do one analysis on top of the data, right? And if I build a model, I need to build a matrix, which is about 700 million. Okay.
Is that with the feature selection applied? Or
yeah, that's with the feature selection applied. That's with the feature selection applied. Yeah. Yeah, the total, that's why I said the total is about 2.3 trillion. This is with the feature selection applied.
Can you elaborate more on how you get 700 million for Universal Studios?
Yeah, I just showed you. Basically, if you look at it, the number of possible values, we have about 547 campaigns. We have about 4,650 creators, 4 media channels, 19 brands, right? If you multiply that, I think that alone, you'll probably get there, right? And we are not, if you multiply all of them, and then there are 13 sub-channels, 17 tactics, 164 publishers. Right? So we are not taking all of them, obviously all of the cross sections which are valid.
Question: when you mentioned columns, that implies your structured data, relational data.
No, it's because columns, people understand columns, but features, right? Like I said, features by itself have to have context around it. So each combination of feature and the context, you can consider it as one column, right? And there are 600 million such things which matter to the end outcome.
Then what are your rows? And how many rows?
Those are the rows. Those are the rows actually.
Each row will be, what is each row?
Each row is basically the distinct combination on the values.
Then you are what is your target variable?
Target value. So here, what we are trying to basically go and predict, the outcome variable that we typically predict is some kind of a revenue predictor. It could be also clicks, number of clicks, right? It could be Google query volume, right? It could be one of the intermediate variables, or it could be one of the revenue. Make sense? Yes.
What's the most interesting target variable in your framework?
Interesting. No, we are we help our CMOs actually go and maximize the revenue spend, and we work with the top brands. Most of them are concerned about revenue, right? At the top level, they were concerned about revenue. So that's our most frequent. We do work with some of the intermediate outcomes. That most of them work with outcomes. And when we started off as a market mix modeling company, and now we do both digital and market mix modeling company. So even today, we help plan the marketing budgets. We also help them optimize their campaigns. Okay, so I think that's fundamentally the problem that we are working with, and to provide a solution, the way I think about it is, in my journey, right? There are kind of two things that gets added, right? Back in the days in 2008, it was very important that you have the ability to work with large volumes of data, right? Because data was omnipresent, and you had to go on and somehow process it. Around 2011, 2012, you had these you needed that ability to, like Twitter and all these guys found that, okay, fine, there are large volumes of data. On the other hand, I need to run analytics really fast, right? And so you had Hadoop around this time, and then around this time you had things like Spark and Storm and so on and so forth, which would actually come in and process these data really, really fast, right? What today's world demands is the fact that you need those, but you need to be able to run huge models, and you need to be able to tell them, it's not just reporting, you need to be able to run these models and tell them what works, right? You need to be able to run optimization algorithms on top of it. And by the way, after 4 years of working with MarketShare, what I've learned is you can't just provide them recommendations. You need to once you provide these recommendations, then you need the ability for the user to run what-if analysis on top of it. And actually, in the increasing order of complexity, right, it goes from here to here, right? I mean, this is hard, this is hard, this is super hard, and this, I think, very few people do what-if analysis, interactive what-if analysis on this massive volume of data. All right. So we had to provide that, and we had to go through, like, a few tools of the trade. Like, we had to have some fundamental things that we had to have, and then few tools. But first of all, is to assemble the right tools, right? Around 2008, when we basically went and worked on these things, Hadoop was very early, and Join Data actually was a Hadoop solution on top of MySQL shard. So we had to basically go and take Hadoop, we had to install it on a cluster, and we had to do it. Today, I think you have managed services that actually go and provide them. There's Tubole, there's Altiscale, and there are lots of other companies which actually go and provide them. We work with Altiscale, and having one of those managed big data services is extremely important. Right? It helps you lower the cost of ownership. At the same time, you can actually have guaranteed uptime and so on. And then there are a few more tools that we use, which I think is invaluable when you're putting a big modeling environment. The first thing is ability to model on all of the data, okay? And in our case, it's not like we always model on top of all of the data. Actually, it does not make sense. So a pure data scientist would come back and say, you never actually go and look at all the data to estimate. You look at a subset of data, right? But on the other hand, I think what we have figured out is, in order to, first of all, convey confidence to the end customer on the model, and for us also to kind of get the confidence, and also have that flexibility for us to vary the amount of data that we can model with. You need a modeling environment which can actually go and look at all of the data, and so we use H2O, which was called OX data before. And there are lots of other companies. There's the Databricks, which actually provides again a big modeling environment, and so on and so forth. And then there are two more tools that we use. The first tool we use is a visualization, is data visualization. And again, we have a data visualization tool. It's called Arcadia Data. And what it helps us do is actually go and look at all of these data and provide run reports on it at near real time. And then we work with an MDM tool there, which is still in stealth mode, so they don't want us to name it. But I can basically talk about it after this, which helps us actually go and understand about the data and understand what data we have. And the MDM tool is extremely important because one of the fundamental aspects of modeling is analyzing or exploring your data, and a tool like that helps you actually do such exploratory analytics much better, right? So the first thing is to kind of get the tool set itself, and then the second thing is have some edicts, right? Whatever model you build has to be able to work with partial data, right? Even though I put up those numbers, what we kind of realized that was the fact that you can actually not run models that big. So you have to have the ability to work on partial data, and the only thing is when you're working with partial data, then it also has to be the fidelity of the model or the outcome has to be trusted, right? I think maintaining that balance is extremely important. Also, this is very true for analytics in general, and it's becoming more and more if you look at the data science world, is the fact that once you get data, it's how fast, especially if you're in a software as a service model, how fast are you able to deliver the tool? With just pure data processing, it becomes easier, but people have solved it. But once you start introducing modeling into it, it's extremely important that you are able to basically deliver quick initial models, which are consistent, which are good, and to be able to deliver the tool as fast as possible. Right. So it's the tool set, and then the edicts that we work with. I'm going to go a little bit deeper into what exactly we've done, but I just want to pause here, take some questions or any comments, anything that you guys have.
MDM is master data
management. Yeah, it's a metadata store. It's very important, especially in the big data, that you have a metadata store, so that you can understand your data set a lot better.
Is there a problem of overfitting your data?
So say that again.
Is there a problem of overfitting the data?
Yeah, all the time, right? Because I think that's what modelers do. They basically go and spend a lot of time in trying to get the perfect model, and so on. So what we have done is we've kind of come up with a way of and again, I would love to hear your experience. We're also going through this journey to a certain extent. Is the fact that modelers used to use statistical rules to validate whether a model is correct or not, right? And once you start using such statistical rules to basically go and do it, you always go through a longer cycle and actually going and getting the data itself. So in the analytics pipeline, we've introduced a business rules-based evaluation engine where our selection criteria is based on the business rules, that as long as the business rules are satisfied and whatever the model is supposed to basically go and provide, our model is good enough, right? As opposed to satisfying completely the statistical rule, right? And that has helped us actually go and speed this process up. And I have it, I think, in my list. Does that make sense?
Of all the tools in the market, how do you choose which technology you're planning to do?
So data science, I personally think that we are living in a golden, I mean, I've seen this, right, as 2008, I've seen it 2012. We are in the golden age for data science. I think personally, there are a plethora of tools which are coming up, which on all of these fronts, like, big data infrastructure, like, I mean, I don't even understand the difference between Hortonworks and Cubole and like EMR and Rackspace and so on and so forth. There's so many infrastructure components to choose from. There's so many big modeling tools to choose from, and so on and so forth. So the way we've done it, I think in a startup, and this is just my experience, is like, we kind of do an A/B test, and we are a startup, we're a small company, we cannot afford it. So we do an A/B test along with a customer thing, and then we evaluate our business metrics, and that's how we evaluate, right? So for example, when we work with OX data, we work with Revolution R and OX data, and we basically built a model on it, and then we had some few criteria that we had to work with, and we found that OX data suited our things a lot better.
So do you see Spark as predictive or something?
Yeah. So the way I look at it is, you have historical data and you have large volumes of data. Processing of that is going to be primarily Hadoop based, and it's still and it's not going to be purely Hadoop. It's going to be like some kind of a SQL engine on top, because I mean, at least that's my viewpoint, that if you have a SQL processing engine on top of Hadoop, it's much easier to process than plain vanilla Hadoop. So primarily that's going to be the case. But what's going to happen is, and that's how we employ it. Like for example, on the other hand, for your hourly processing, daily processing, or something which actually goes and reaches you need to basically have the data reach the end user faster. So those pipelines, right, Spark would start dominating. The big challenge about Spark versus Hadoop is the cost, because it's purely in memory. The cost of the infrastructure is going to be, at least for us, it was pretty significant. So we restricted to our incremental data pipelines, Spark, as opposed to historical and all that we still process on.
So I was curious about, you had said that the most difficult part of doing the analysis on those large data sets was doing a real-time what if. And was that because of the number of variables that can be changed? It's very difficult
exactly.
to do that real
So
time.
I'll give you an example, right? Hilton, the marketing budget is decided by the corporate, okay? But the marketing spend is owned by the individual properties, right? So what has to happen is the strategy is set by the corporate company, but on the other hand, once you set the strategy, these guys have to basically go and implement it, right? So what happens is, when you are looking at, when each property is trying to basically, and that was our thing, we're trying to look at their campaigns, and they're trying to basically go and say, okay, fine, how am I going to go fine tune it, and so on and so forth, right? That's when that explosion happens for Hilton, right? And I'm sure there are other Universal Studios I can come up with. So yeah, it is the number of things that you want to basically go and change in your model. So you had, and I know that I don't know how good a job I'm doing, but basically you had these static reports which are staring at you, right? And you had to basically go look at the reports, and then you have to do something. You want to play with the data. You want to basically go and say, fine, this is what I'm telling you, but I'm not going to accept it as is, right? Even though you're actually telling me what it is, I want to change it. I want to basically go and accept, like if you provide 10 recommendations, I want to accept 6 of them, but there are a few constraints I'm with, so I'm not going to have the other 4, and I want to run it. And now, can you tell me what the impact is going to be? Am I making the right decision? And again, the explosion comes because there are so many points that you can basically go and change.
of the lifespan of the model, once you run with the model for a customer? How long can they keep using the model before they have to come back, build a new model?
It's a very subjective, all of these are very subjective questions, right? Like I'm just being, I don't know if folks have figured it out, but I'll tell you what we do. We estimate the model every week. We estimate the coefficients on the data. The re-estimation of that happens every week. Every quarter, we actually go and rebuild the model, which means that we come up with a new model.
How far off is your model from the previous quarter? How far off, like on average?
See, I'm not a modeler, and unfortunately, I mean, I don't know the answer to it, but I can find that out. I don't know the answer to it. If you ask a modeler, they would say, like, no, it was all great. I was just looking at it. We have this constant dialogue. I don't know how often. Sorry. But that's a good question. I'll get back to you on it.
So how large is your data science team?
We have about 40 PhDs in statistics and in econometrics.
So you said like every week you re-estimate the model, and then every quarter you rebuild the model.
That's right.
Now, how do you evaluate? Like once you...
Yeah, that's what I'm saying. So what happened is, and I'll talk about it later.
Okay.
So our model evaluation was like previously it was all statistical, and that's like a very different way of actually going and doing it. And what we've learned is statistical rules that do not cut it, because I think at the end of the day, and somebody asked this question on how do you know the model is perfect, right? No model is perfect, by the way, because you're playing God, right? You're basically going and saying what's going to happen next year. So, but the question is your business rules, and if you do your business analytics reasonably well, and as long as it satisfies the constraints of the business, then your model is good enough, right? So what we had to do is we had to come up with a rules engine, which went and so you get all those requirements, and you basically build this rules engine, and the rules engine evaluates the outcome, make sure that it satisfies the constraints.
So do you have clients that object to the SaaS model due to privacy concerns with the data?
No, till now we have not had clients object to the thing. But see, that's where I think your infrastructure stack. We no longer actually. There are lots of companies which actually go and provide infrastructure services which are portable, right? I don't think SaaS companies should basically own this problem, as opposed to you should offload it to an infrastructure services. There are lots of companies out there. So we work with Elastic Box. I don't know if you know this company, which ensure that they make sure that they provide us a container that is portable, and if there is a private cloud, they would be able to install it as long as they satisfy all the requirements that we have. We have all these things that we need to be installed. As long as this is there, the deployment and managing and monitoring of it is their responsibility, right? And like I said, I think in 2008 when we built Jovian Data, we had to build this entire infrastructure deployment and so on and so forth, and it was a reasonably significant part of our team, right? Nowadays, there are lots of companies which actually go and provide portable services, where once you build the service, you can actually go and deploy it on a private cloud as well.
The validity of the model also depends on the variables you can provide. For example, once you've seen with your customers, what are the variables they wish they have but don't have? No, it's going to be there.
It's again a modeling question. Right. So I think I'll have to defer it to a modeling. And again, if somebody kind of takes notes, I'll make sure that those questions are made. Right.
What's the business model?
What's MarketShare's business model? MarketShare's business model is basically a license fee for the software and some consultant services fee.
Is it dependent upon how much data is,
how
many queries are being run?
See, I think again, you're asking an engineer this question. I know we only know how to spend. We don't know how to get the revenue. So again, I'll try and get that answer.
just curious, would you be able to walk us through this?
Yeah, I was planning to do that.
Yeah,
just
because
pausing for
right now
question.
it doesn't, like,
It doesn't gel, right? Yeah. So should I say? Yeah.
Yeah, I had another question. I'm not sure if you're going to get into it. Something there with ETL. Can't tell. But have you ever had any issues like merging some data sources that are just almost unmergeable? Like, for example, like website data,
Yeah.
mobile data.
So I think one is the whole cookie matching, right? And in our case, we have some proprietary algorithms for actually doing the cookie matching to a certain extent. And then, but again, I think which is good. But I think if I started the company today, right, there are like a few companies who specialize in that, who actually go and specialize in how do you basically go and not only multi-device, not only on a single device, they actually help you come up with matching across devices. So there are the aspects. So there are lots of folks who are focusing on just that area. On how do I basically go get a single identity across your iPad, iPhone, whatever. So, but yeah, we have our own algorithms to basically do that. All right. So I'm going to go briefly over the workflow. This is something that we can actually go and spend an entire hour on. So I'm going to go briefly over it, but I can dive into any detail, any part of it that you want details on. So we get data, and it's a very regular ETL flow, and I don't want to spend too much time on ETL flow. I really think that ETL is well understood, and we follow the best practices for ETL. We use Kettle on top of Hive. And we are evaluating Trifactor, which is basically a machine learning ETL tool on top of this, and it's not the only tool which is available. There are lots of ETL tools that are available in the market, which can actually go and make your data engineer's job a lot easier, right? So we run ETL on top of it, and then our modelers actually go build models on top of it, and then once the models are built, we actually go run attribution, which is our scoring. We actually go and score the models, and then the data which is scored is then fed into our tool, which is facing the customer, right? And this is a distributed tool, and we've spent quite a bunch of time in actually going and optimizing how do you run what-if analysis at such scale. Some of the salient points of this is, one of the things that we found out was when you run what-if analysis, the update frequency is actually as important as read, which is a very peculiar problem in analytics. In analytics, generally you're worried about reads and you're worried about large amounts of read. Remember, when you're doing what-if analysis, you're changing values all the time, and it requires large volumes of changes, and the update is extremely important. And what we figured out was, even now, I think in terms of, there are lots of these big data tools, but if you want to actually go run what-if analysis, nothing can beat Oracle, because it's kind of good in both reads and writes. SAP HANA or things like that would actually be much better than all the big data environments. So our what-if analysis actually runs on those relational databases as opposed to the big data tool. Another thing we figured out was, from when you're running math, it is very important that you separate out the data access. You don't do the data access within math. So we have a layer called a DSS, which is stands for Decision Support System, and the main function for that, of course, is our vision is, of course, it will basically go and be a full-fledged scheduler for all these complex math algorithms. But for now, it abstracts out the data access in the sense of the read and the write of the data, and then it keeps it in a language which is more familiar with, whereas use MATLAB only for actually going and running the math, and not actually doing data analysis, right? And we use memcached for basically going and doing a lot of pre-calculations, which would actually go and help us during optimization and scoring.
Question. What you mentioned a couple ETL tools. What are they again?
So we use Kettle. We have Kettle for actually going, and Kettle is like Informatica and all that, except it's open source. And then we use Kettle on top of Hive. We are evaluating There are lots of machine learning ETL tools that are coming into market. Trifactor is one of them. We are evaluating Trifactor.
Thank you.
Wait, what are you evaluating?
Trifactor.
Fact, not the horses.
I'm sorry, when they say machine learning ETL.
So what happens is most of the time it's like there's a lot of data exploration, and then you need to figure out where, like you have an output that you desire, and it's a multi-stage output, right? Usually it's a human endeavor in actually going and creating these SQL scripts, which looks at this input, and then you write up like a set of complex SQL to run it. And you have tools like Informatica and ViewSchedule, which is basically a it's a UI-based tool where you don't really have to write SQL. You can do a visual, you have a visual environment, but it's still, most of them use SQL to run it. Especially in big data, it becomes really complex. So what's happened now is there are lots of companies which has come in and says that, okay, fine, I'm going to generate the ETL code myself. You just tell me what the output is and what the input is. And again, it's a big promise, not realized. That's why it's still under evaluation. We will figure out how to basically go and get the desired output from all these inputs. And the way it does it is they say that you initially you do it, and then we learn from you on how you do it, and then slowly we'll get better and better at ourselves figuring out how to basically go generate the desired output.
It's like you provide an output that's a sum value.
Yeah.
And somehow it's going to try to find how to get that sum.
Exactly.
Figure out that it's
Exactly.
somehow-
Exactly. And then again, like I said, it's machine learning, which means that I think you work with the system. So the data engineer, of course, like in terms of cost, again, these are things that I want to validate with you. A majority of the cost is spent here and here, right? To a certain extent, your data engineers and getting the data and just processing the data, you spend a huge amount of time. Second thing is, of course, modeling, you spend a huge amount of time. So if you want to reduce cost, we are evaluating. There are lots of there's another company called Paxata. There are a few companies which are trying to basically solve that. So that's at the surface, and then there are some few things that that we did. One of the things that we felt is important is you have to keep the model building pipeline and incremental data pipeline, data refresh pipeline separate. What does that mean? As soon as the data comes in, we come up with the initial model, and then that model basically goes and feeds it into the tool. Right? It's the initial attribution model. How we come up with it, I'll go into the details later, and that is separate. Whereas modelers would work on the side, actually going and working on the models on an ongoing basis. Right? Probably obvious, but again, we kind of came up with this thing.
A quick question. So I didn't quite understand. So you mean, so you're refreshing your model? That's what your incremental data refresh pipeline means when you refresh the model based on a new data?
Yeah. So what we do is as soon as the folks, as soon as a client signs up, we have an initial model for him, and then we get the data, and on a daily basis, we basically go and make sure that the scoring happens on the model and we refresh the model and so on and so forth. That's a very separate pipeline. And somebody asked this question on Spark. This is where I think Spark helps quite a bit because it speeds up the daily refreshes and so on and so forth. The model building pipeline, on the other hand, which is actually going and building the models, that's an offline thing, and that happens on the site. And it's important to keep these two things separate. And the tools that are used,
Historical data?
Yeah, it's historical data. But the tools that you use for here and here are different. So you keep these two things separate, and then the second thing is you need ways of actually going, and especially when you are working with models and number of variables this big, you need to have methods where you can actually go and reduce the number of variables automatically, right? And we use various statistical methods. These are actual numbers. If you look at hit and the initial number of variables, not the coefficients, initial number of variables is in the order of 5,000, and then we use various statistical techniques to reduce it to 110 before we actually go and feed it to the next stage, which is an automatic model generation routine. So we get that we get the reduced number of features, which is called the modeling spec, and then we use genetic algorithm to actually go and create the models themselves, and then we use Bayesian priors to restrict the model's personal space, right? And like I said, the evaluation not only has statistical analysis, but it also has business rules with it. And then this is an iterative algorithm. It goes through n number of iterations, and the whole name of the game is how do you basically reduce the number of iterations and produce a model as fast as possible, but again, which satisfies these business rules. Okay. So having something like this, and this whole modeling environment, we do it on H2O. Right. So now I went through a whole bunch of stuff, Bayesian and genetic and things like that. I mean, I think it's going to be, by the way, H2O basically provides Bayesian out of the box. Bayesian is nothing but, you saw the coefficients. Basically, it provides a bound on which the estimates can be anything, right? And the algorithms can throw any estimates. Bayesian helps you configure these bounds. So it basically goes and says your coefficients have to be within these bounds. So it helps you control the model better. So that you're not going wild in your set space. And genetic algorithm, and there are like lots of model search algorithm. Genetic algorithm is a type of algorithm which basically goes and gets the best possible model based on a previous iteration.
So it seems like a number of models are going to be generated, and the best is going to be selected.
That's
generally, like I know there's like you use an ensemble of models, right? But in this process, it seems there's only one model that's going to be the output. So you're basically using just one model and
That's
not
right.
like an ensemble.
That's right. Not an ensemble. And then I've heard other people actually go and do it, where they basically go and do that. But at the end of the day, when you are, and again, like I just want to have this validation. At the end of the day, when you are actually going and using it for a prediction for the end customer, right? I mean, you cannot use multiple models, right? Because today the big challenge is, I mean, like in 2000 to 2010, it's all reporting and so on and so forth. Data science is just coming into fore, right? You're predicting the future. You're basically going and saying this is what is going to happen. So the biggest thing that you want to gain from the customer is confidence. You need to basically go and display confidence in the results. When you use multiple models, right? And then let's say for some things, like for Hilton, let's say for a property, I'm using a model, right? And at the global level, I'm using a different model. And then I predict something on the property level, I get some number, right? On the global level, I use a different model, I get a different number, right? It becomes a challenge. I understand that there are other things like confidence intervals and so on and so forth, which you can basically go and specify and you can still get there, but it becomes a lot more complex to do it. At least we actually, even though of course we have we have multiple models and all that, but at the end of the day, for a customer, we use one model, right? It becomes a lot easier to convey confidence. Anyway, it's all hocus pocus, so at least you can give one.
What about execution speed? Is it irrelevant?
So we are able to generate a model within 8 hours of the data coming in. That's our latest numbers.
That's the quarterly reviewed or the nightly or weekly?
No, the first model, I mean, any model, the new model be rebuilt or a model, it doesn't matter. In our case, the model rebuilt and the model is basically the same, right? So it's about 8 hours. And just as a comparison, without this, if you actually had people manually built it, and please don't, it's being recorded. So to a certain extent, it's nothing to do with market share modelers. It would take us 3 to 4 months to come up with a model.
coefficients that you spoke about, do they play a role in the model analysis?
Yeah.
Are they auto-corrected or
Yeah.
is there?
So coefficients are the most important, the features and the coefficients are the most important aspect. And like I said, the Bayesian priors basically help control the coefficients to a certain extent, so that, like, one is basically you come up with some value of the truth, right? Bayesian Bayesian priors actually go and help make sure that the truth is controlled for a longer period of time.
So does somebody manually go and check the result of?
So we have business rules, which basically goes and evaluates. We have a series of tests that basically goes and evaluates, and we run a whole bunch of scenarios that happens. At the end of the day, it's the same thing, right? Like, say, if you remove all the predictive analytics and so on and so forth, all you're doing is you're saying, okay, fine, I'm going to spend $10 million for this campaign, $5 million on this campaign. Can you tell me what the value of the sales is going to be, right? That's what you're going to ask, right? These are all analytics questions that folks ask. So there's nothing different, right? So we use those rules to evaluate the
Can you give an example? Visual execution speed. Do you find it possible to speed it up by deploying more computing resources, or is it a cap that you just have?
I don't think so. It's a number of iterations that we have a problem right now. Right now, I don't know if it's going to be like each iteration itself takes a long time. The number of iterations that takes is come up to
Can you give me an example of business rule being used to validate the model, like maybe a very high-level example?
So that's what it is. It's basically, this guy says that paid search efficacy is twice as much as display. Right? And it's somebody has found it out for a long period of time. You can't argue with them, right? And you would say that if I do something and I put some money in paid search, then I would get X amount of sales. The same money I basically go and put it in display, then I would get, like, half of that or whatever, right? And models, of course, models say it, and there are business guys who basically believe in this, and so on and so forth, and so on. So those are the type of rules that you are basically going and evaluating. How is your model predicting? So if your model is basically going and doing the opposite, where it says that, oh, I'm doing this increase, putting it in paid search, you're getting half of the display, right? And there's something wrong.
Can you highlight that?
Yeah.
Like, since you're saying you're going to validate with the business rules, which means that everything is done inside the box and kind of black box, and the business will just get.
Yeah.
So if it's kind of a conflict.
No, it's not. I mean, it's in the sense that there is a discovery. I mean, this is not like you are not going to. There is a journey that you pass through, right? And you learn things. And then there are certain things you're still learning, and so on and so forth. So these are things that you've already learned about the data, that you know is true. There are certain things that you know that that is true. This is and again, like I was saying, I personally think data science is in the seed realm right now, right? Actionability is the thing. It's like, you have to convey confidence, and you have to be able to say that it works.
I'd like a question that's twofold, but the last bullet point that you have, best to reach first reasonable initial model, is awesome. I was first going to ask you what you define as reasonable in terms of your clients. I know everyone has different impressions on what they feel should be a good fit.
So we have confidence intervals for our attribution.
Yeah.
We basically have confidence interval.
Yeah.
We have 3 levels of confidence intervals, right? So the first confidence interval is very loose, right? And it's fine. It's just that it doesn't break basic rules that we know about the data, right? Whereas our ACV for clients is about $1.5 million, right? When you go to a client, it's about $1.5 million, right? At that time, I think our confidence intervals are pretty high.
Good to know, yeah, because I was just wondering how you explain that to clients. But my second part of that question would be, some clients may not understand data.
We buy them expensive wine. So yeah, I can give you a lot of answers. So basically, we have something called we have a huge reporting aspect. That's why visualization is extremely important, right? And I think what happens is you can come up with whatever model you want. You have to be able to explain a model, and if you look at it today in the data science, that's the first order problem. The first order problem is not able to come up with model. I can come up with some model, right, which is like, makes sense. How do I convey confidence is basically by exactly what you said, is to be able to come up with some kind of a visualization which explains the result that comes in. And that's where the MDM tool that I talked about, and I think that the big data visualization engine are your friends, along with a business analyst.
In traveling up with the model, you can use all the data and feed into it, and it comes to efficient, or you can have, say, a certain percent holdout and just run the rest.
All the time. Okay. When somebody's paying $1.5 million in a year, I mean, that's like, that's table stakes. You have to get a hold of. Has to satisfy them. Every client of ours. That's basic, right? That's how they validate predictive models. The good news is I really think that most of them are able to get beyond the bar. I don't think that itself for a statistician is a problem. They understand how to basically go and build models which can work on holdouts. And then once we decompose the data, then the data itself is decomposed. So let me kind of like spend a little bit of time here. Here what's happening is there's the end sales, and then we have the historical data and the future data, and we have the future sales also as part of the data, and we've actually gone and we've come up with how the spend actually contributes to the sales, right? We have the decomposed sales, which is contributing to the end outcome. Then if you have like a question or an analysis, let's say in the Hilton's case, person is analyzing only the property. So we only take data which is concerning that particular property instead of all of the Hilton data, and then we fit a model at runtime, right? And then we do what-if analysis on that model instead of this big giant model that we went and built. Right? And that's along with all the distributed aspects of how we built, along with memcached and pre-calculation and so on and so forth. This is a big aspect of why we were able to provide interactive analytics on top of the data. We never actually go and look at the 600 million variables. Instead, if suppose you're working on 10 data elements, you only look at 10 of those elements. But we are able to fit a model within those 10 of the elements, and that model is accurate, and we use that model to basically go run simulations. That's how we actually provide these.
Just to get real quick for a time check, how many more slides do we have?
I think.
It's amazing. I mean, the talk's going real well. I haven't seen anybody nodding off or anything. So,
which is
how many more slides?
Step. Yeah, no, I think.
Because this, I mean, it's great. I mean, we're doing well. We've got plenty of time.
Awesome.
Question, the equations you have in the third box, are those generic or are those specific?
Yes, specific.
Optimization. So those are the equations that are actually used by the Cobb-Douglas optimization?
Yeah, Cobb-Douglas is a form of equation, right? So it's just a form of equations, right? So we have a model form, and we have different model forms depending on the data itself, and then we fit a model.
And this is in real time.
That's why it's in real time. I wish I had internet which I was looking at. I was actually going to show you one here, and you can actually go on like do a slider, and you can get results. As you're moving the slider, you get results.
And the data is, it must be reduced to column.
Yeah, I mean, the data for that particular simulation is like, okay, whatever element that you're working on, that's it. There's nothing else. But I think the total data that you can analyze from the thing is, of course, the entire data. But when you're working on, when you're trying to basically go create a scenario, what you're working on is only that data that you need. Yeah.
So what's in the black box? Oh, that's where
that's the tool.
So you deal with time series models as well?
Yeah, I mean, yeah. Fundamental thing is time series.
And do you provide confidence intervals?
That's right. Yeah, we do provide confidence intervals. Again, those are bread and butter, right? Like, you know, I'm sure anybody who provides it has to provide confidence intervals.
So where is the offline model here?
So the offline model is only running the attribution on top of the offline model is running the attribution on all of the data, and it is telling how much of these channels actually contributed to the sales for that particular model. So it's run there. Whereas when you're running some analysis, we actually go run an analysis on the model form which we selected at runtime. On top of it.
So what do you mean by attribution? Is it feature selection?
Attribution is basically how did each of those channels, how much did they contribute to the sales? Like for example, what percentage of your sales is contributed by, let's say you had like display, paid search, and TV, right? Even like what percentage of your sales is coming from each one of those channels? That's what I mean by attribution. Okay.
So do you have a standard UI, or is it a different one?
No, we are a multi-tenant SaaS application.
You also mentioned you were making use of maybe third-party visualization tools.
That's true. For just the visualization, actually we use two. We use Arcadia data for big data visualization. We also use Tableau, and historically we've used Tableau because nothing to beat that. So all of our reporting and all that is from Tableau. But the problem with Tableau was it was not able to run on big data directly, and it became a huge problem. That's where Arcadia comes in. Arcadia can actually go and provide this visualization. All right, thank you. I really enjoyed it. I think I'd love to, again, like, you know, I'd love to reach out to you folks and then learn from you on what you have done on these. Hopefully I was able to kind of present this. This is a pretty complex topic, and as you can see, I've been 4 years into this, right? I've kind of learning this myself, so it's a difficult topic to present, but hopefully I was able to convey what we were able to do, and then we continue this dialogue.
Thank you.
Thank you.